In this example, we're given some data based upon hitting a golf ball on the planet Uranus. Notice how we're given 5 times and the corresponding heights at that time. Uranus has a gravity of approximately 28 feet per second squared compared to Earth's 32 feet per second squared. In this first question, we're asked to use the quadratic regression feature of the graphing calculator to generate a mathematical model for this situation. And we're asked to round each coefficient to the nearest whole number. So the first step is to enter the data into the calculator. To do this, we press the Stat key and then Enter. If you have any old data in the columns, you can press Up, Clear, and then Enter. It will clear the entire column at one time. For L1, we'll enter the times, and for L2, we'll enter the heights. So L1 will be 1, 2, 3, 4, and 5. And for L2, we'll have 102, 147, 164, 153, and 114. Now we can perform the quadratic regression. So we'll go back to the home screen by pressing second mode. And now we'll press Stat, right arrow once to calculate. We want quadratic regression, which is option 5. So we can press 5. Now I have a newer version of the TI84. Notice how on this screen I can go ahead and enter where I'd like the equation to be stored. So I'm going to arrow down to this cell here and enter y1, so the equation is automatically stored in y1. So I'll press vars, right arrow, enter, enter, and now the regression equation will be automatically stored in y1. This is optional. We could do the regression and then enter the equation manually into y1. So now we go down to calculate and press enter. If you have an older version, you just press enter once you have the quadratic regression on the home screen. So here's our quadratic function, and notice how if we also press y equals, we can also see it here. But be careful here, we want a function h of t, so we're not going to use x, we're going to use t. We'll have h of t equals negative 14t squared plus 87t plus 29. And now we have a series of questions we'll solve graphically on the TI84. So before we address these questions, let's go back to the calculator and get a nice view of our graph. So before we press graph, we do want to adjust the window. So I'll press the window key. And I've already determined what values are going to work. Sometimes this can be a bit challenging. We want the x-axis, which is really the t-axis or the horizontal axis, to go from negative 2 to 10. Let's go ahead and scale it by ones. And we'll have the y-axis, which is really the h-axis or the vertical axis, go from negative 20 to 200. And we'll scale this by 20s. Of course, the scaling is optional. Let's press graph and see how this looks. This is a pretty good view of our quadratic function. Going back to our questions, based upon the model, how high is the hill from which the golf ball was hit? So the key to answering this question is recognizing that when the ball is hit, that's when time t equals 0. So looking at the graph, that would be the h-coordinate of this vertical intercept. So to do this on the calculator, we can press second trace for calculation, and then option 1 for value, and then enter our next value of 0, which is really t. And notice how it shows us the vertical intercept is the point 0, 29, and therefore at time 0, the initial height was 29 feet, and therefore the hill had a height of 29 feet. Without using the graphing calculator, we could determine the height of the hill by evaluating our function h of t at 0. Notice h of 0 would be 0 plus 0 plus 29, or just 29. Next, we're asked to use the model to estimate how long the golf ball will take to reach its maximum height and what its maximum height will be, and we're asked to round to 2 decimal places. So going back to the graph, we can determine both of these answers by determining the vertex, or this high point, of our quadratic function. So because it's a high point, we'll use the maximum feature of the calculator. So we'll press second trace, option 4 for maximum, and it's asking us for the left bound. We want to move the cursor close to the vertex but remain on the left side. So maybe somewhere in here, we'll press enter. For the right bound, we move to the right side. Maybe somewhere in here, press enter. When it says guess, we can just press enter again. Notice how the coordinates of our vertex show below. To 2 decimal places, the time would be approximately 3.11, and the height would be approximately 164.16. Let's go ahead and record this. So the golf ball reaches a maximum height of, again, that was the output or function value of 164.16 feet after approximately 3.11 seconds. Remember, the first coordinate, or t, was approximately 3.11. If we want to do this by hand, we could use our formula here for the vertex, where the t-coordinate would be equal to negative b divided by 2a, and the h-coordinate would be the function evaluated at negative b divided by 2a. Now for the last question, we want to determine how long it will take for the golf ball to hit the surface of the planet Uranus, where it has to round to 2 decimal places. So going back to the graph again, notice how the ball is going to hit the ground here at this horizontal intercept. So to find this point, we can use the zero feature or the intersection feature. Let's use the intersection feature. To do this though, we have to go back to y equals, and in y2, we want to enter y2 equals 0. This represents the horizontal line h of t equals 0, where all along this line, the height would be 0, and therefore the ball would be on the ground. So if we go back to the graph, notice how we can't see the horizontal line along the horizontal axis because it's on the horizontal axis. But we know it's there, and therefore we can use the intersection method to determine this horizontal intercept. We can press second trace, option 5 for intersection. Now we want to move the cursor closer to this horizontal intercept. There's 2 of them, and it's going to find the one the cursor is closest to. So let's just say somewhere in here. And now we can just press enter 3 times. Enter, enter, enter. Notice at approximately 6.53 seconds, the height, which is our function value, is 0. And therefore the ball would be on the surface. So the golf ball will reach the surface of Uranus after approximately 6.53 seconds. If we wanted to solve this by hand, we'd have to set h of t equal to 0, which would give us the equation 0 equals negative 14t squared plus 87t plus 29. But in order to solve this, we'd have to use the quadratic formula. I hope you found this helpful.